final video, we're going to wrap up section 7.3, solving trig equations, and we'll get to the ones with multiple angles, and we'll use inverse trig functions to solve these. So, the next two examples involve trig functions of multiple angles in the forms of the sine of something times u or cosine of something times u. To solve the equations of these forms, first solve the equation for that multiple angle, then divide your result by the constant in front. You know, in all the other examples, this would have been 2 cos of t. Now it's 3t. It's a multiple angle. So there's just one little tiny thing we got to do different when we approach these problems. Well, first we want to start just like we did in the previous ones. We want to solve this for the trig function. So we're going to add 1 to both sides. 2 cos of 3 times t is equal to 1. And then we're going to divide by the 2. So we get the cosine of this angle 3t, and I'm going to put it in parentheses, is equal to 1/2. So now, you know, if it was cos of x equals 1/2, we could just go to the unit circle. But we can't apply that here. So let's do a inverse trig function. How do we get rid of cosine? We take the cos inverse of it, and they cancel. So we also have to take the cos inverse of this side. And we're going to be left with the angle 3t is equal to, what is the cos inverse of 1/2? So where on the unit circle are our cosine values equal to 1/2? So that occurs at 1/3 pi, right here, and also at 5/3 pi. So we're going to have 1/3 pi, and we're going to have 5/3 pi. So then I broke this into 2 pieces here. Where does cos inverse equal 1/2? Well, it happens at 1/3 pi. So we have 3t equal to that solution, 1/3 pi. And then we also have another solution at 5/3 pi. So we set this same multiple angle, 3t, equal to that 5/3 pi. Ooh, and I don't like the look of that 3. Okay, now we're going to just solve each of these separately for t. And we also want to remember that we were not given a restricted angle on this, or interval, from like 0 to 2 pi. So this occurs at pi over 3 radians, plus every 2 pi n after that. And also this 5/3 pi, that also occurs every 2 pi n after that. Now, this is sort of like what we did in the last one. We got to solutions that look like this. Now we just have a 3t, so we want to divide by 3, or multiply by 1/3. If we divide this by 1/3, or divide by 3, we're going to get pi over 9. Plus, we have our 2 pi n, and we divided that term by 3. So there it is, t equals 1/9 pi, plus every 2 pi n after that. And we'll do the same thing here. We are multiplying by 1/3 or dividing by 3 to get t by itself. If we multiply this first term by 1/3, we get 5 pi over 9. Plus, divide this term by 3, and we get 2 pi n over 3. Now, I can't remember if the book that does these examples, I can't remember if they get a common denominator here. We could make this into 6/9, and then, you know, get a common denominator and make that one big numerator. Leaving it like this is fine, though. So here in example 8, we have, in the previous one, it was a multiple angle like 3 times x. Now we have a fraction of an angle. This is a 1/2 x. But the idea is going to be pretty much the same. Let's solve here for our trig function of tan 1/2 x. So we're going to subtract 3 from each side. 3 tan, and I'll write it this way, of a 1/2 x is equal to -3. And then divide each side by that coefficient 3. So we will get the tangent of a 1/2 x is equal to -1. And then we tan inverse to get our angle alone. Tan inverse the left side, so we get 1/2 of x is equal to the tan inverse of -1. Okay, where on the unit circle do we have tangent values -1? Well, tangent is sine divided by cos, so that's going to occur at the 4 places where sine and cosine have the same values, root 2 over 2. And now then we'll just have to think about the signs. When we divide and get a negative 1, the signs have to differ. So that's going to occur here at 7/4 pi and here at 3/4 pi. So 3/4, 3/4 and 7/4. So a half x equals 3/4 pi, and a half x equals 7/4 pi. And we'll have our plus 2 pi n. Plus 2 pi n. Or if you notice when I had the unit circle up there, 3/4 and 7/4 are directly across from each other. They are symmetric around the y-axis. So we could just do one of these answers times 1 pi n. And let's do that. I'll just pick this one. A half x equals 3/4 pi plus 1 pi times n. And that will account for this other one here. And we still haven't gotten x alone. To get this to be 1x, we are going to multiply both sides by 2. So here they will cancel, and we're left with x equals. We will have, when we distribute, 6 pi over 4, or 3/2 pi. Plus, we would distribute the 2 also here, and we would have a 2 pi n. Now, in this next example, you're going to see how inverse trig functions can be used to solve an equation. Oops. So we have secant squared x minus 2 tan of x equals 4. And our trig functions are different, so we're going to use a Pythagorean identity. This secant squared we can replace with a 1 plus tan squared. So that becomes a 1 plus tan squared of x minus 2 tan of x. And let's subtract that 4 from both sides. Now over here we'll have a minus 4, and it's all equal to 0. Collect our like terms. Tan squared of x minus 2 tan x. We have a plus 1 and a minus 4, and those add up to a minus 3 equals 0. Now, hopefully this will factor nice. Tan squared has to be tan of x times tan of x. And we have a minus 3 and a minus 2, so that our factors are going to be a minus 3 and a plus 1. And now we're ready to set each of those factors equal to 0. So on the left here, tan of x minus 3 equals 0 means tan of x equals 3. And we also have this, tan of x plus 1 equals 0 means tan of x equals negative 1. So we're solving here for x. We'll do the tan inverse. So here we will do the tan inverse, and those will cancel. So we're going to get x equals the tan inverse of 3. And the same here. Tan inverse will cancel. And we're left with x equals the tan inverse of negative 1. Okay, on the right-hand side, where does tan inverse equal negative 1? And we found some points like that earlier. That's where sine and cosine have the same values, but the signs are different. And that's going to occur at 3/4 pi and at 7/4 pi. So we could move this over. We could write this as x equals, that would be 3/4 pi plus pi n. Now on the other side here, Where is the tan inverse equal to 3? Well, there are spots where that's going to occur, but it's not going to happen on one of our nice angles that we've been using in the unit circle. So this answer we're going to have to leave as x equals the tan inverse of 3 plus pi times n. So 3 practice problems. Pause the video, check them out, come back and check out the solutions. Okay, here in number 39 we have a multiple angle, the cos of 2x equals a half. And our trig function is already isolated. So let's cos inverse both sides. So those will cancel, and we're going to have 2x equals the cos inverse of a half, positive a half. Where does cosine equal positive a half? Well, that's at pi over 3 and 5 pi over 3. So we're going to have 2x equals pi over 3. And 2x equals 5 pi over 3. And these are also, remember we have laps around the unit circle, plus 2 pi n. And another plus 2 pi n. So we want to solve for x, divide by 2, or multiply by a half. So we're going to get x equals pi over 6 plus, when we divide here by 2, those will cancel, pi n. Same on the other side. We want to get rid of the 2, so we're going to sort of multiply by a half, or that's the same thing as dividing by 2. So we'll have 5/6 pi plus pi n. In the next one, just like the last, we do have our trig function is already isolated. So the sine of a half x equals this value. Let's sine inverse both sides. So those will cancel. And we will have x over 2, or a half x, equals the sine inverse of negative root 3 over 2. So where on the unit circle do we have y values of negative root 3 over 2? Well, that's right here at 5/3 pi, and also here at 4/3 pi. So 5/3 and 4/3. So this a half x, 1/2 x, equals 5/3 pi, or let's do the 4/3 first, 4/3 pi, plus every lap around after that, plus 2 pi n. And then we also have our 1/2 x is equal to 5/3 pi plus 2 pi n. And now we just have to get x alone, so we're going to times it by 2, multiply by 2. This is going to be x equals 8/3 pi plus 4 pi n. And then here multiply by 2, and we get x equals 10/3 pi plus 4 pi n. And the last one here, get that out of there. So use inverse functions where needed to find all solutions across this interval from 0 to 2 pi. And we have something that looks quadratic, and it's all in terms of tan already, so half the work's done. We have something squared plus something minus 12 equals 0. Well, we can factor that like so. Tan squared must be tangent times tangent. The factors of 12 that multiply and they're negative, and they add up to positive 1. Well, that's got to be positive 4 and negative 3. So we can set each factor separately equal to 0. So the tan of x plus 4 equals 0 means we subtract 4 from each side. So tan x equals negative 4. And tan x minus 3 equals 0 means tan of x equals positive 3. And that would be plus pi times n. Plus pi times n. And to get rid of tangent, we want to do arctan or tan inverse. So the tan inverse will wipe that out, and we'll have x equals the tangent inverse of negative 4 plus pi n. And here the tan inverse will cancel that out. X equals the tan inverse of 3 plus pi times n. And homework for this section